Hello, dear students. I welcome you all in this class. So, today we are going to discuss lecture number 3 of this amazing chapter chemical reaction and equation. So, let's begin without any delay. Let's move on to the next slide. Okay, guys, so here we are. So, here we will discuss types of chemical reaction. Yet we have seen lots of things. We know how to balance a chemical equation, how to write a chemical reaction, and many more. But here we will see what are the types of chemical reactions. So mainly there are 5 types of chemical reactions. First one is combination reaction, second one is decomposition reaction, and third one is displacement reaction. Fourth one is double displacement reaction, and fifth one is redox reaction. Okay, now one by one we will study these reactions. So let's move on to the next slide and let's talk about the types of chemical reactions. So guys, here I am. Here we shall discuss combination reactions. Okay, so what is of combination reaction? First of all, we will try to understand this. Combination reaction is a reaction where two reactants combine to form one product. Okay, so reaction in which two or more reactants combine to form one single product, then this will be known as combination reaction. So this is a general term for combination reaction. Here you can see this is an element, or you can say this can be a substance, and this is also a substance, or it can be an element. So when these two reactants combine and gives us a single product, then this reaction will be known as combination reaction. Okay, so here one example is also given. And what is this example? So when magnesium is burnt in the air, magnesium oxide is formed. So basically, whenever we burn something, so burning simply means making the substance or the element react with oxygen. Okay, when we are burning something, so what we are doing, we are actually reacting it, or you can say making it react with oxygen to form a product. So what happening here? Magnesium is burnt in the air and magnesium oxide is formed. So in this reaction, magnesium is combined with oxygen. So guys, this is the chemical formula of magnesium oxide. MgO is what? Magnesium oxide. Magnesium oxide. And guys, you should know the chemical formula of the substances, because when the question comes, then they will not give you the chemical formula, they will simply give you the name, and you have to find out, or you can say you have to have knowledge of the chemical formula of that substance, then only you will be able to do this question, otherwise you cannot do that. Okay, so guys, this is what? This is an element magnesium, and this is in solid state. Okay, so you have to remember that metals can be in solid state. Okay, like you can say they can be in separate form. They do not need any other, or they do not need to combine with other metals or the other element. They can be live in their pure form. Okay, so that's why this is in pure form. You can see that there is no other element from which this magnesium combined, but this is oxygen, and this is basically O2. This is what? O2. So this O2 means this is a gas, this is a gas, and here you can see that element of oxygen is combined with other element, and that is also oxygen. So that's why I written O2 here. Okay, so this O and this is 2, and this 2 is basically written downside. Okay, like this O2. I hope guys you might have been able to understand this point. Now guys, what will happen when this magnesium and this oxygen reacts with each other, then they will give us MgO, and that is magnesium oxide, and because two reactants are reacting and giving us a single product, so that's why this is an example of combination reaction. I hope guys this thing is clear to you. Now let's move ahead and let's talk about some more examples of combination reactions. Okay guys, so here we are. Here we will see another example for combination reaction. So when carbon is burnt in oxygen, carbon dioxide is formed. In this reaction, carbon is combined with oxygen. So guys, what happens? I told you that whenever you burn something, so it simply means that you are making that element or the compound react with the oxygen. So what we are doing here, we are making this carbon react with oxygen, and carbon here is solid. So it might be charcoal. It is charcoal, and this charcoal where carbon is present, so this carbon is reacting with oxygen. And how will I write oxygen? I will write oxygen by its chemical formula, and that is O2. Okay, because O makes compound, or O combines with the other O element or the other oxygen element. It will not present in the single form, or it will not, the single atom of oxygen will not be there. They are always combined with each other. So guys, when this charcoal reacts with oxygen, then it will give us carbon dioxide. This is what? This is carbon dioxide. Carbon dioxide. So basically this di comes for twice. Here you can see the number of oxygen is 2. So that's why I wrote di here, carbon dioxide. Now guys, after understanding this, let's talk about some more examples of this combination reaction. You might familiar with quicklime. Quicklime. So what is this quicklime? This quicklime is basically, we call it calcium oxide. Calcium oxide. Okay. And what is the chemical formula of calcium oxide? So the chemical formula of calcium oxide is CaO. Here it is calcium, and this is oxygen. This is oxygen. Okay, so this is calcium oxide. Now guys, you have to remember the famous name of this compound. This is called quicklime, because when we solve questions, then they will not give us the chemical formula, or they will not say that calcium oxide. What will they give us? They will call this calcium oxide as quicklime. So we should know that what is the meaning of quicklime, or this is a famous name for CaO, means calcium oxide. So you should know the famous names of the compounds. Okay, so as soon as we move ahead, I will keep telling you the famous names of the substances, so that you will not face any type of difficulties while solving questions. So guys, what I was telling you, that whenever this quicklime reacts with water, whenever this quicklime reacts with water, so it makes a compound, and that is CaOH whole twice. Okay, and this is known as calcium hydroxide. This is what? Calcium hydroxide. Okay guys, so basically guys, you can see that this is quicklime. This CaO is quicklime, and after it reacts with H2O or water, this is the chemical formula of water, where two elements of hydrogen is present and one element of oxygen is present. So when these two reactants combine with each other, then they will give us a single product, and that is CaOH whole twice, and this is what we call calcium hydroxide. And there is another famous name of this CaOH whole twice, and that is we call slaked lime. Let me write it here. Slaked lime. Okay. So you should know these two things. First one is quicklime. Second one is slaked lime. Quicklime is CaO, calcium oxide, and slaked lime is calcium hydroxide, CaOH whole twice. Okay. So guys, what happens? This is an example of combination reaction. And in this reaction, what happens? Whenever this quicklime reacts with water, it gives us calcium hydroxide, and heat is also evolved. Heat is also evolved. Let me write it here. Heat. Okay. And I hope that most of the students might have seen happening this reaction at your home. Okay, so let me tell you how you can see it. So you know that for painting a house, we purchase this quicklime from a shop. Okay, this is a quicklime. So when we mix water in that quicklime, then the calcium hydroxide is formed, and this calcium hydroxide is painted on the walls. This calcium hydroxide is painted on the walls to for shining the walls. Okay, and in this reaction you might have seen the container in which you mix quicklime and water. This container heats up. Why? Because of this reaction. Because in this reaction, the quicklime, when you add water in it, then lots of heat is evolved. So that's why the container becomes hot. Okay guys, I hope you might have seen this reaction at your home. So this slate lime is used to paint our houses. Now guys, I will tell you what is the cause of the shining on your walls when you paint it with calcium hydroxide. So basically, let me tell you here. So when this calcium hydroxide, reacts with carbon dioxide, then it gives calcium carbonate. It gives calcium carbonate, and this calcium carbonate is responsible for the shining on our walls. Okay, because of it, the shining of the walls, you can say our wall starts shining. So basically guys, how we get this carbon dioxide? Because we know that whenever we paint our walls with calcium hydroxide, then the carbon dioxide is present in our atmosphere. So this calcium hydroxide will react with the carbon dioxide which is present in the air, and then it forms calcium carbonate, and this is what? This is the reason for the shining of our walls. I hope guys this thing is clear to you. This is very important thing. Okay, so now let's move ahead and let's talk about some other things. And before moving ahead, let me write the name of this CaCO3. It is known as calcium carbonate. Okay, guys, I hope these things are clear. Now let's move ahead.
So here student, we will see what is endothermic reaction and what is exothermic reaction. Okay, so firstly let me explain you what is endothermic reaction. So guys, endothermic reactions are the reaction which absorb heat. Okay, to give you an example on this, let's suppose I'm taking calcium carbonate. This is what? This is calcium carbonate. Now, after observing the heat, this calcium carbonate will convert into calcium oxide and carbon dioxide. Okay, what will happen? This calcium carbonate, after observing the heat, it will become calcium oxide and this carbon dioxide, and this CaO is what? This is quicklime. Okay, we have already seen this. So guys, this is an example of an endothermic reaction. And why it is endothermic reaction? Because you can see here, this heat is given to this calcium carbonate, and after observing heat, this is producing quicklime and carbon dioxide. So guys, thus this is an endothermic reaction, and you can say that endothermic reaction, or in endothermic process, this observe heat and cools the surrounding. After observing heat, it will cool the surrounding. So what are the endothermic reaction? Let me write the definition of endothermic reaction. So a reaction in which system absorbs energy from its surrounding in the form of heat. A reaction in which system absorb energy in the form of heat. So those reactions are known as endothermic reaction in the form of heat. So this is the definition for endothermic reaction, and this is the example. I hope by this example this is clear to you that what is an endothermic reaction. Now, after understanding the endothermic reaction, let's try to understand what is a exothermic reaction. Exothermic reaction. So basically guys, these exothermic reaction are just opposite of endothermic reaction. Basically in endothermic reaction, heat is given, but here it releases the heat. It means heat is released in these type of reactions. So you can say that the reaction in which heat is released are known as exothermic reactions. Okay, reactions in which heat is released heat is released are known as exothermic reaction. Now guys, what could be the example of exothermic reaction? So you can also think by yourself by of the examples of exothermic reaction. Let's suppose if carbon is reacting with oxygen, then carbon dioxide is formed, okay, which is a gas, and this oxygen is also a gas, but here carbon is in solid form. Let's suppose you can say that burning of a coal. So when you burn a coal, then lots of heat is released in this process. So this is also an example of exothermic reaction because heat is released in this process. So I hope guys this point is clear to you that what is an exothermic reaction. Now guys, we can also see the other example of exothermic reaction, and that is when the calcium oxide, this calcium oxide, when it reacts with water, then it will form calcium hydroxide. What will it form? It will form calcium hydroxide. And in this process, heat is released. Okay, you might have seen that whenever you bring calcium oxide at your home, then when you add water inside it, then it will release lots of heat. So this is an example of exothermic reaction. And this calcium oxide is in solid form, this is in aqueous or liquid form. Okay, so I hope guys this thing is clear to you, that what is an exothermic reaction and what is an endothermic reaction. And guys, it is also very important to know that exothermic reactions, or you can say most of the combination reaction, what we have just seen, that what is a combination reaction. So combination reaction, or you can say most of the combination reactions are exothermic, and most of the endothermic reactions are decomposition reactions. Okay, and what is decomposition reaction? On the upcoming in the upcoming lectures we will be talking about decomposition reaction, so you do not need to be worried about it here. I will be telling you what is decomposition reaction on the later slides. So I hope this point is clear to you. Now, after understanding this point, let's move on to the next slide.
So guys, here we will talk about an example, and let's see what is this example. So when water reacts with quicklime, what is your observation? Okay. So what is this question is trying to ask? So basically nothing. It is asking us the observations. And I had told you in the previous slide that whenever we are seeing an equation, so we should know the chemical formula of that equation. Okay, that is very, very important. Now guys, let's suppose what he has given here. So let me write solution. So in this question, it is said, then water reacts with quicklime. So first of all, we should know what is quicklime. So quicklime is, I told you, CaO, calcium oxide. Okay. And what is the chemical formula of water? We know the chemical formula of water is H2O. Okay. So when this quicklime react with water, then it will give us calcium hydroxide. This is very famous reaction. I explained this reaction twice. So that's why you should know that about this reaction. Okay. So this is what? This is calcium hydroxide. Calcium hydroxide. Okay, but he is asking that what is your observation? So guys, when you make this reaction, then what will happen? The heat is evolved. Heat is evolved because this is a type of exothermic reaction. Okay, exothermic or endothermic? Exothermic reaction. Why? Because heat is evolved. Okay, guys. So, what is our observation? We will simply say that in this reaction, calcium hydroxide is formed and heat is also evaluated. This is our observation. I hope guys this thing is clear to you. This the chemical formula and their famous name. The famous name of this calcium hydroxide is slaked lime. I told you that slaked lime. Okay, and this is we are very frequently taking its name quicklime. It is basically quicklime. Okay guys, I hope this example is clear to you. Now After understanding this example, let's move ahead and let's talk about the other type of chemical reaction. So let's move on. So students, decomposition reaction is another type of chemical reaction. So what happens in decomposition reaction? It is just opposite of combination reaction. Opposite of, let me write it here, combination reaction. Okay, how it is opposite? Because in combination reaction, two or more than two reactants combine and form one product. But here, one product will break, or you can say one reactant will break into two or more than two products. Okay, so in combination reactions, reactant combines, but here the reactant is decomposed into the different products. So that's why the name of this reaction is decomposition reaction. I hope this thing is clear. Now guys, let's read this. Reaction in which one compound decomposes into or more compounds or elements are known as decomposition reaction. So a decomposition reaction is just the opposite of combination reaction. It is opposite of what? Combination reaction. A general decomposition reaction can be represented as follows. AB is splitting into A and B. On the other hand, in combination reaction, A plus B was combined to form AB. Okay, so this is the difference between decomposition and combination reaction. Now guys, let's talk about the examples of decomposition reactions. Okay, so basically the example of this decomposition reaction, we will take the same example which we had seen in the previous slides as well, to make you understand the endothermic reaction. Okay, so I told you there that most of the endothermic reaction, not all, but most of the reactions or endothermic reactions are the decomposition reactions. Okay, so you can say that this is a endothermic reaction. We had seen this reaction when I was explaining endothermic reaction. So here you can see that when we provide heat to this CaCO3, which is calcium carbonate, so this calcium carbonate was broken into the two compounds, that is calcium oxide and carbon dioxide. Okay, this is CaCO3 and this is what? Calcium carbonate, calcium carbonate. Okay, and this is CaO, which is calcium oxide, and CO2 is what? Carbon dioxide. Carbon dioxide. Okay, so this is an example of what? Decomposition reaction. I hope guys this thing is clear to you. Now guys, let's move ahead. Okay, and let's talk about the types of thermal decomposition. So what we are studying? We are studying the types of chemical reactions. We had studied two types yet. First one is combination reaction. Let me write it here. First one is combination reaction. The second one is decomposition reaction. Decomposition reaction. Now, this decomposition reaction has also three types. This is also three types. First one is thermal decomposition. Thermal decomposition. Let me write clear for you here. Okay, thermal decomposition, and the second one is electrolytic decomposition. Okay, and the third one is photochemical decomposition. Photochemical decomposition. Okay, so we will see these three type of decomposition reactions one by one. Here, the example which is given here, this is an example of thermal decomposition. Okay, so basically guys, what is happening here, this is basically the lead nitrate. This is what? This is lead nitrate. Let me write it here. Okay, and guys, this lead nitrate is in solid state, and this is a colorless substance. This is what? This is a colorless substance. Let me write it here. Colorless. Okay, now guys, when we heat it, or when we give heat to this substance, then it will break into these three substances, or you can say this will break into these three products. So this is what? This is lead oxide, this is lead oxide, and this is yellow in color. Let me write it with other pen. Lead oxide, and this is yellow in color. Okay, now this is the second product is nitrogen dioxide. Nitrogen dioxide. Okay, and you will see the brown fumes of nitrogen dioxide. Brown fumes of nitrogen dioxide. So students, if you don't know what is fume, so let me write here for you. So fumes are basically, you can say these are smoke, or you can say these are gases, and smell of the fume is very unpleasant. Okay, and sometimes it can be dangerous. If you breathe in, then it may be dangerous for you. So fumes are what? Fumes are the smoke or gases that smell unpleasant. Okay, so I hope guys this thing is clear to you. So what do you have to remember? This equation can be directly asked in the observations. Okay, so you can be asked that if you provide heat to lead nitrate, then what is your observation? Okay, so what do you need to say? That time, two things you have to remember. First one is the formula of this lead nitrate. Okay, so what is the formula of lead nitrate? That is PbNO3 whole twice. Okay, this is the formula of lead nitrate, and this is in solid state. This is in what? Solid state. So if you provide heat, then it will convert into the lead oxide, and you can see that lead oxide is in yellow color. The color of lead oxide is yellow, and the fumes of nitrogen dioxide is brown. So you will say that if we provide heat, or if we heat up this lead nitrate, then it will break into lead oxide, and we also see the brown fumes, or the reddish brown fumes of the nitrogen dioxide. So this will be your observation. I hope guys this first type of decomposition reaction is clear to you. Now let's move ahead and let's talk about the second type of decomposition reaction. So this is the second type of decomposition reaction, electrolytic decomposition. So guys, it is very simple. Why it is so simple? Because here we will decompose a compound, but in this particular case we will provide it electrical energy. What we will give? Electrical energy. So we will break this compound in the components using electrical energy. That's why this decomposition is known as electrolytic decomposition. Okay, so for the example you can see here, this is a compound and basically this is water, and this is made up of two hydrogens, two element. This is hydrogen, and two hydrogen elements are combined here, and one element of oxygen. So this will basically, this is made by the hydrogen and the oxygen. So if we provide electricity in water, then what will happen? It will break in the hydrogen as well as oxygen, and these both are the gases. This is a gas and this oxygen is also gas. So that's why in bracket I will write gas. And we provide electric current into this liquid, this water. So this is in liquid state. So that's why we will write L in bracket. Okay guys, I hope this thing is clear to you. So the reaction in which compound decompose into simpler compounds because of passing of electricity, these are known as electrolytic decomposition. And if you are asked the examples, then you can directly give this example where water is broken into hydrogen and oxygen when we pass electricity through it. So I hope guys the second type of decomposition reaction is clear to you, that is electrolytic decomposition. Now let's move ahead and let's talk about the other part, or you can say the other type of decomposition reaction, and that is photochemical decomposition. So students, here we are. So photo decomposition or photolysis decomposition, because it is a type of decomposition reaction, so here also we will decompose a compound or a substance, but in this type we will provide light energy. We will provide light energy. And how do we provide light energy? By passing sunlight over it. So then the compound will break into the simpler compound. So you can see that reaction in which a compound decomposes because of sunlight are known as photolysis or photo decomposition reaction. And this is an example of the photolysis where this AgCl, this is what? This is silver chloride. This is silver chloride. So here guys, this silver chloride is basically a white substance, and when you provide sunlight, then it will break into these two simpler components, and that is silver and chlorine. Silver and chlorine. So silver is gray in color and this chlorine is a gas. Okay, chlorine is a gas, and I told you in the beginning that non-metals basically is very rarer found in pure form. Okay, they will live with their elements or in combination, but metals can be found pure in nature. Okay, so this is a metal, silver, so this will break in Ag and this will break in Cl2, which is a gas. So this is an example of photolysis or photo decomposition reaction. Okay, so photographic paper has a coat of silver chloride which turns into gray when exposed to sunlight. It happens because silver chloride is colorless while silver is a gray metal. Okay, so basically guys, what happens, this silver chloride is used in black and white photography. Okay, in the olden times, you might have seen that photographers works in a dark room. Okay, so why do they work in dark room? Because if there is presence of sunlight, so this AgCl, which is used in photographic paper, it will convert in Ag and Cl2. So this AgCl is what, white, or you can say it is colorless. But this Ag is gray. So when this AgCl converts in Ag, then the color of the paper will become gray, because Ag is, the color of Ag is gray. Okay, so that's why you might have seen that in the olden times photographers used to work in a dark room because they do not want to break this AgCl which is used in photographic paper. Okay, so here a very important uses of silver halides, a very important use of silver halides we know, and that is photography, black and white photography. Black and white photography. Okay guys, so what is silver halides basically? So silver halides is basically a compound where one element is silver and the other element is halogen. Okay, what is halogen? Halogen is basically chlorine, okay, and fluorine and bromine, iodine. So basically guys, these are the halogens. Chemical formula of this chlorine, Cl, fluorine we simply denoted by F. This is Br and this is I. So these are the halogens, and if these halogens is made a compound with silver, then we will call it silver halide. So silver halides are used in black and white photograph. I hope guys this thing is clear to you. Now, so I hope you enjoyed this lecture. So now I am winding up this session. So thank you so much, and we will meet in the next lecture. Bye bye.